Welcome back to the deep dive. Our mission today is a bit like drinking from a fire hose.
That's a good way to put it.
Yep.
We're taking a huge stream of technical updates from just one day, January 9th, 2026.
And we're going to distill it all down. The goal here is to give you pure, actionable insight from this flood of information.
Exactly. Because staying on top of innovation in the Microsoft ecosystem and tech in general, it feels like a full-time job. So we're ripping through 8 domains to give you that shortcut.
Not just the what, but the why. The strategic shifts that actually matter for your next project.
Or your next career move.
Okay, let's jump in. Where do we start? The foundation, I guess. Core cloud infrastructure.
Section 1, yeah, Azure and Microsoft 365. And if you look at Azure strategically, the direction is, well, it's just so obvious.
AI at scale.
At an astronomical scale. I mean, the biggest headline we saw was Microsoft's strategic AI data center planning.
They're laying it all out in the open.
They are. They're designing the literal geography of the cloud to handle massive deployments of the new NVIDIA Rubin GPU architecture. They're not just adding servers, they're redesigning the map.
That's the huge 50,000-foot view, but you and I know it's the details on the ground that can trip you up.
Always.
Take point-in-time restore for Azure SQL Hyperscale. We saw a documentation that basically warns restores can take longer now, so why is that little detail such a massive headache?
Because hyperscale is for your most critical workloads. When you design for disaster recovery, you need predictable RTOs, your recovery time objectives.
And longer than expected is not predictable.
Not at all. It means your RTO is now a question mark. So any high availability environment now has to reassess their entire strategy, maybe even budget for more expensive options. It's a classic reminder that scale adds complexity to recovery.
And while that gets more complicated, new features are still rolling in. We also saw Azure PostgreSQL AI capabilities pop up.
Right, bringing AI functions right into the database. Now, shifting gears a bit to Microsoft 365, the theme is similar. It's all about reducing friction for administrators, but through an AI lens.
We saw the small stuff like the SharePoint Framework Toolkit update. Necessary, but not groundbreaking.
Bread and butter, yeah. But the strategic move is in the management tools.
And this is where it gets really interesting for me. Admins are starting to manage M365 with natural language.
Using tools like the CLI for Microsoft 365 MCP server. And this isn't just a chatbot wrapper. It points to a fundamental shift.
A shift in how systems talk to each other.
Exactly. And that shift is built on something called the Model Context Protocol, or MCP. If you remember one acronym today, make it this one.
So what is it?
The MCP is an open standard. Think of it as a Rosetta Stone that lets any AI agent from any company access external data and tools in a secure, standardized way.
So you're saying the barrier to entry for building a really complex, powerful AI agent just plummeted?
It just dropped through the floor. It's democratization on a huge scale. Before, you had to write custom API wrappers for everything.
So what's the risk?
The risk is that if every agent can suddenly speak this common language to get at sensitive data, the controls have to change. You have to focus on securing the agent, not just the API.
Which is probably why we're also seeing things like always-on diagnostics for Purview endpoint DLP. You need effortless troubleshooting when the complexity is hidden inside an agent.
Precisely. And that idea of the agent, it's a perfect transition into our second section, low code.
Power Platform and Dynamics 365.
The whole conversation there is moving away from old school, rigid workflows. We're now contrasting classic cloud flows with these new agent flows.
And the agent part is the key. What does that imply?
It implies an autonomous layer.
Yeah.
An agent flow can use that MCP to talk to a dozen systems, decide its own path, and pivot based on the context it finds.
All without a human having to map out every single possible branch?
Exactly. So Copilot Studio becomes the place where you assemble these AI brains. Developers can consume an MCP server right there.
So you're making this incredibly sophisticated, context-aware AI a native part of the low-code world.
Yes. It closes the loop. It ties right into that power of data message we saw, where you're encouraged to bring in custom machine learning from Azure directly into the Power Platform.
The pace of this is just incredible, and it raises huge questions about the underlying code and infrastructure, which I think leads us straight into Section 3.
It does. The future of coding, DevOps, and SRE. Because the speed of these agents demands a totally different way of thinking about code.
We started by looking at the quality of AI-generated code.
But the real focus was on Anthropic's Claude Code and its influence on this idea called vibe coding.
Vibe coding, I have to admit, that sounds dangerously casual. What does that actually mean?
It's a new paradigm. The developer uses AI to generate code, but they're prioritizing creative flow and super fast iteration. It's less about perfect structure up front.
It's a collaboration.
A very tight, almost stream of consciousness loop between the human and the machine. You're just exploring ideas, letting the AI handle the boring parts.
Hold on. That sounds like a recipe for disaster. If you prioritize speed over structure, isn't the technical debt going to be astronomical?
That is the central tension of 2026. The speed is addictive, but the messiness is very, very real. And it's already causing problems for our infrastructure.
How so?
We saw articles debating if serverless architecture is failing modern AI agents.
Failing them. But serverless was supposed to be the promised land of scaling.
It was designed for stateless, event-driven functions. Quick in, quick out. AI agents are the opposite. They are stateful, they're context-heavy, they need persistent memory of what they're doing. Serverless struggles to hold that state efficiently.
So what's the answer? We saw this term agentic metadata being floated as the next infrastructure layer.
Right. So if VMs manage hardware and containers manage dependencies, agentic metadata is the layer that manages the state, context, and security of the agents themselves.
It's a management fabric for the brains.
A dedicated layer to track an agent's mission, its memory, its permissions as it moves through your systems. Is the infrastructure finally catching up to the application model?
And for anyone wanting to get their hands on this, there was that lab for GitHub Copilot in VS Code.
But the big takeaway is this. In 2026, AI isn't just a tool for engineers anymore. It's merging with platform engineering itself. The lines are just evaporating.
Which brings us to the architecture of AI itself, Section 4, Data, Analytics, and AI.
And the big question here is scale. If these agents are everywhere and they're stateful, how do you scale them without, everything grinding to a halt?
The sources mentioned agentic AI scaling needs a whole new memory architecture.
Precisely. The old models don't work. And beyond memory, you have complexity. You need multi-agent orchestration. We saw a lot of emphasis on patterns for that.
Like an air traffic controller for your AI fleet.
That is a perfect analogy. You have multiple agents all working on one request, one for customer data, one for logistics. You need a manager to orchestrate their work, handle failures, and stop them from stepping on each other's toes.
It's a new design pattern. On the tooling side, things are getting a little confusing. We need to clarify the difference between Microsoft Copilot Studio and Microsoft Foundry.
Good call. Copilot Studio is primarily the user experience platform. It's for building the conversational front ends, the interfaces.
The part the user talks to.
Exactly. Foundry seems to be the deep engineering and data platform. It's for building the robust, scalable back-end data pipelines and AI applications that power everything. Think of it as the industrial strength engine room.
And the one skill that connects these agents to the real world.
Mastering LLM tool calling. This is what makes them useful. If an LLM can't make an API call to update a customer record, it's just a text generator. Tool calling is a framework that connects the intelligence to actual business functions.
We also saw some very pointed career advice. For data scientists, the sources said the best domain to be in for 2026 is supply chain.
Yeah, the return on investment for sophisticated modeling and supply chain is just unparalleled right now. It's high value, it's data intensive, and the problems are complex enough to keep the best people engaged.
Okay, let's pivot. All this data, all these agents moving around. Section 5, digital defense, security compliance, and privacy.
Strategically, AI is forcing a complete rethink of security. It's the classic arms race. Attackers use AI for better phishing. Defenders use AI orchestration to automate threat detection.
And we see that MCP protocol again, the Microsoft Sentinel MCP server.
It's the perfect use case. A security agent needs to pull data from Sentinel, check user behavior, look at privacy rules in Purview, and then maybe trigger an action in Defender. MCP is the standard language that lets it do all that in milliseconds.
We also saw some new tools like the Microsoft Defender Expert Suite and a public preview of a dynamic threat detection agent.
Right, tools designed to find those hidden threats that traditional signatures miss. But the core strategy is about protecting the data itself.
Which is Microsoft Purview Data Security Posture Management, or DSPM. We should probably define that.
DSPM gives you deep visibility into your sensitive data, where it is, who's accessing it, and how to mitigate the risk no matter where that data travels. Old security protected the network, DSPM protects the data.
A necessity in a world where agents are moving data all over the place. We also saw an open source contribution, OpenAEV, for testing these systems.
Which is great to see. Now, if the tech is changing this fast, the skills have to change too. Which takes us to Section 6, learning, and certifications.
Foundational skills for 2026. The list highlighted a beginner's course on OOth 2.0.
That's the table stakes. You cannot build secure, modern applications or agents without understanding modern auth flows. It's just non-negotiable.
And beyond that baseline, the focus was pure AI skill building, a crash course on agentic AI workloads, an intro to knowledge agents.
In practical labs, like building an autonomous news assistant agent, notice the language. It's not about theory anymore. It's about building workloads and autonomous systems.
And then there was one very strong piece of advice for developers wanting to future-proof themselves.
Learn Rust.
That's a powerful statement.
It is. It shows that as these agents scale up, the need for performance, safety, and memory efficiency is becoming critical. And that's pushing demand for powerful languages like Rust.
Okay, let's zoom out for our last section, macro trends. What's happening in the wider world?
Starting with the global tech race, we saw a new report on protecting the U.S. lead in quantum. The focus is all on quantum error correction, or QEC.
The deep foundational science.
The really hard, really expensive stuff that makes the whole thing possible someday.
In the more immediate AI world, Microsoft acquired a company called Osmos.
To accelerate autonomous data engineering in Fabric.
Right, it's a huge signal. They want the data pipeline that feeds the AI to be entirely self-managing and self-optimizing. You need a perfect, self-healing data supply chain for a massive AI engine. Tying back to vibe coding, we saw a new open-source coding model from Noose Research, NooseCoder 14b.
Which helps democratize that AI-assisted development, putting powerful tools in more hands.
But the biggest trend, the one that really underpins everything we've talked about, it wasn't technical at all.
No, it came from executives at McKinsey and General Catalyst. They stated, very definitively, that the era of learn once, work forever is over.
That one statement really captures the urgency of all this, doesn't it? It's not just a nice slogan anymore.
It's a fundamental reality. If the infrastructure you build on changes every 6 months, if the code you write is a collaboration with an AI, then your static knowledge becomes unstable.
Continuous reskilling isn't just a benefit anymore.
It's the core mechanism for professional survival. You have to be learning these new protocols, these new development patterns, these new security models right now.
So let's try to pull all this together. The big theme is the total integration of these autonomous AI agents, standardized by protocols like MCP, into every single layer of the tech stack.
And that's driving a new culture of programming. Vibe coding, incredibly fast, AI-assisted, and powerful. But the complexity is also rising.
The power available to people who master these new tools and understand the risks is just unprecedented.
And the urgency to learn skills like Rust or master frameworks like tool calling, it's mandatory.
So building on that, we have one final provocative thought for you to think about. If vibe coding prioritizes speed and flow, it is inevitably creating more security gaps and more technical debt.
So what new vulnerabilities are we quietly pushing into production right now?
And if that debt is real, what does production ready even mean anymore in an age of generative code? And how quickly will we need that agentic metadata layer just to clean up the mess the agents are making?
The speed of progress is incredible, but that stability question is still wide open.
Something to think about. Thanks for joining us for the deep dive.